which we won't do today, we'll do it Tuesday. But we're gonna do this by doing 2 more models. I hope we get through the second one, but we're gonna do 2 more models. And one of those models is actually gonna be a break-even analysis model. We'll talk about that. And then, I don't think I have a data table on that one, but then we'll have another model just for more model building and using a tool today called GoalSeek, and using data tables to go with that and how we end up using it. We won't get to Solver today. We will first do this break-even problem. In this break-even problem, we sell a part that for $300 that we could have made in one of 3 different ways. We could either outsource it, where we have to pay a $5,000 setup fee, which is nice and low, except then the variable cost of the item now is $200. Or we could buy a machine that's a little bit more manual, that's an $80,000 machine, so it's kind of expensive, but that would lower our variable cost down to $75 a unit. Or we can buy the super duper fully automated machine. It's very expensive, it's $200,000, but that could get our variable cost all the way down to $15 a part. We're not sure which of these is the best way to go. Well, if you look at that and the way that that's set up, what you have to figure out is if you have the demand that would justify you buying expensive machines in order to get those really reduced variable costs. And you may or may not have that. That's what we're gonna have to figure out what it would need to be. So we are gonna do a break even on each one of those options, but then we're also going to compare those options to each other and see when would we switch from one to the other. The next problem we're gonna do if we get to it, we'll probably just talk about it when we get to it, but all these numbers are actually on the spreadsheet already. I think we'll talk about that when we get to it, because I'm not positive how far we'll get, but we'll talk about that problem and its associated questions when we get to it. There is a model right after that, and you will see it on the finished file probably today, but if not today, on Tuesday. And it's this grade model. We're not gonna do it in any of the classes, partly because of the lost time, but partly because my main purpose behind this model was so that you would just have it, so you could plug your own grades into it and use it to figure out, what your grades would be. Because for a long time, we're gonna be doing linear optimization problems, all the way up to the last test. Because of the nature of the way we do our grades, we don't just have a straight, all your tests are 25, 25, 25. That'd be easy. Or the first one, the second one, the third one, that'd be easy. But it's not. Your highest grade is one, your middle grade is different, your lowest grade is another, and that makes this a nonlinear model. And we aren't really doing nonlinear, and so that was always kind of a little problem in and of itself. But when you see the finished file, you'll see this completed, not something you have to study for, just save it and use it whenever you want to, analyze your grades. Okay? But I don't think we'll get to where we can actually go through it. And then all the solver stuff, that will start Tuesday. We'll start on solver on Tuesday. So let's see how far we can get right now. So here's my, ready for my first problem. It's the one that is telling me that I produce a part, $300, sell it for $300. I have 3 different ways to figure this out. Not a ton of information, but enough information for us to do the break even, because we've got all the fixed and variable costs associated with it. This is just the way I'm setting it up right now. I'm gonna put together the things that are in common between the 3 different options and then list the options out separately. So for instance, regardless of which method we choose, which one of these options we choose, we are selling it for $300. Okay, so that's a given. And in fact, that's a given.
That's an input, right?
That's an input. It's a given input value. We are told this on the PowerPoint, there it is, that's what we sell it for. Okay, so that's a given input, hard-coded in value. That's pretty much the only in common thing, but we do realize that regardless of how we make this part, demand will be whatever demand is. People buying it don't know how we made it, okay? So demand will be whatever it is. Now it happens that demand right now is an uncertain variable to us. I mean, we don't know what it is. We could put in predictions, but that's not what we're trying to do on this one. But we'll look at demand. And while the cost structure may vary, the revenue will not vary between the different options because the revenue will be how many did you sell? What was the selling price? Well, there it is, selling price, demand. So revenue is the same regardless. It is basically your selling price times the units sold. Okay, that's it, selling price times units sold. Now, I don't have anything in the demand cell, so of course it says 0 at the moment, but anyway. Then, I'm gonna break out the 3 different options. Okay, there is an option 1 where we would outsource. There's an option 2 where we would buy a kind of a little bit more manual type machine. There's an option 3 where we would buy the fully automated machine. Okay. And we have some information about those 3 options. We have their fixed and their variable costs. That's what we need. So we have their fixed, we have their variable. But anyway, we have their fixed, we have their variable. Just so you know that you can look them all up, those are given numbers, so I'll go ahead and make those blue. So those are just givens. Okay, fixed for this first one is $5,000. The variable cost then is $200. But if you do the manual machine, it's an $80,000 machine, and that gets the cost per unit down to 75. If you do the fully automated machine, it's $200,000 machine, but you get the cost down to $15 a unit. So those are given. Those are given. Okay, coming straight off the PowerPoint, that's the stuff that we know. Now, from this, we'd like to figure out what total cost is, and therefore, what profit is. I mean, that's like what we would like to figure out now that we know what we have here. Okay, so every piece of information we have off the PowerPoint is here. It's on here. We have everything that we need to do what we need to do. How would we calculate total cost? What would it be? What would we do to get total cost?
It would be the fixed plus the variable times the demand.
Right. The fixed cost plus the variable unit cost times how many units, which that's demand. Make sure when you reference the demand cell that you make that one an absolute reference. Okay, I don't know that you put things in the same cells that I did, but it's your fixed cost plus your variable cost times the demand cell, but the demand cell has to be an absolute reference. And of course, these numbers should look just like this, shouldn't they? When you haven't produced anything yet, your total cost is just the fixed cost. There haven't been any other costs yet. So that should look exactly like that. And then when we go to calculate profit, well, profit is always what?
Revenue minus cost.
Revenue minus cost. And revenue, when you reference that cell, make it an absolute reference to it. Revenue minus the total cost cell. So again, that number should look perfectly normal too. If you haven't produced anything, you've got a loss of your fixed costs.
And if you can go back to total cost again.
Yes.
So it's C8.
Now, I don't know if your stuff's in the same cells that mine is in.
Oh, okay, that's.
Yeah, don't do my cell references. Just do fixed cost plus variable cost times demand.
Fixed.
You might be on a different row than mine, or different columns, or whatever. Okay, we're set up. We're ready to go. We have all of the information in here. But now when I go to do the break-even analysis, that's independently, I'm going to do a break-even analysis on the first option, the second option, the third option. So, one of the things that I'm gonna be looking at is break-even is when profit is zero, okay? It's when your revenue and your costs are equal to each other. So, that's gonna be my outcome cell that I'm looking at right now. I'm gonna shade it gray, because I'm just looking at option one initially. Okay, full disclaimer, you will always on a worksheet only have one gray cell. Okay, you just have one output cell that you're looking at. On the finished file, see, we're gonna be doing this like 3 times. We're gonna end up doing 2 more things after that, so actually there are 5 times in total. So when you pull up the finished file, it has more gray cells, but I have arrows pointing at them, and I say we did these independently of each other. Right now, all I'm doing is the first one. And how could I figure out when that's zero? Well, pull out a calculator, do some algebra, play around with the demand number, trial and error till I get that to zero, or use a tool called goal seek, which will be even easier than us trying to get at it ourselves. So here's what goal seek does. It's under what if analysis, so make sure that your active cell is in the profit for option 1 cell. Make sure it's there. Go to the data ribbon, go to the what if analysis where you found data tables, and here you'll find goal seek. Okay. All right. It's under what if analysis because it is a what if analysis, but it's looking at it a little differently than we sometimes do, okay? Like a lot of times when you think of what if analysis, you think of, what if I change this input? What would it do to my output? What if I change this input? What would it do to my output? What if I change this? What would it? Okay, so we always think like in that direction. Well, this is thinking in the other direction. And it's saying, what if I want a particular outcome? How do I change an input to get that outcome? Okay. I know specifically what outcome I want. How would I get there? How could I change something that would get me there? Okay, so that's kind of the reverse thinking of, I'm just gonna change these to see what happens to the outcome. It's no, I have an outcome I'm looking for, and I'm gonna let something change, make something change to reach that outcome. Okay, that's what goal seek is. So, first thing is what is the cell that you're trying to set to some value? Well, what break-even profit is 0, right? So revenue and costs are equal to each other. So cell F8, I would want to set that to 0. I want to set cell F8 to 0, and I want to do that by changing the demand number. Now, could I, like I said, trial and error plug numbers in there? Sure, I could trial and error plug numbers in there until I figured out what the number was.
How does, like, on a test, like, will you specifically say use a goal seek, or we kind of have to, like, infer?
Wait till after next Tuesday's class to ask that question, because goal seek's going to lead us right into solver, which is going to take us into the things that we're doing. And at that time, I'll be explaining when you could use goal seek, but you could always use solver. Okay, so goal seek is a very unique, limited set of something. But so hold that thought, hold that question till next Tuesday. Okay, so I want to set cell F. Well, I don't know what cell yours is in. I want to set the cell that has your option 1 profit to 0 by changing the cell that has demand in it. Okay, that's what I want to do. And instead of me trial and error or pulling out a calculator, I just click OK, and it slowly but surely turns away on that. And I'm just going to record this number over here. It shows here that at 50 units of demand, I would exactly break even. Okay, I would break even at 50 units of demand. So I'm just going to record that number over here because it'll be changing as I do other things. Now, what that tells us is, if we think demand is going to be less than 50, don't do this. You're going to lose money. Okay. If we think it's going to be more than 50, okay, you're going to make money. Okay? That's what it tells us. But what if I want to know that same information? I want to do a break-even analysis on option 2. Well, the first thing I would do would be unshade this one because I don't want to have 2 shaded cells at the same time. And now this is going to be my outcome cell. My outcome cell is gonna be the profit for option 2. I put my active cell there, and that's where I put my cursor. Go to data, what if analysis, goal seek, and now I'm saying force that profit level to 0. When I force that profit level to 0, by changing demand still, okay, by changing demand, I click OK. Now, again, could have gotten there, Charlie, yep, but this is the number it eventually gets to, a little bit harder to get to, that makes the demand number that makes this have a profit of 0. So to break even, I actually have to sell how many units? 356. Otherwise, I'm still slightly losing money. Okay, and then let's switch over and do this yet a third time, the same thing a third time. Where I'm in the profit cell for option 3, and I want to force it to 0, so go to data, what if analysis, goal seek, force this cell to 0, still by changing demand. So force the profit for option 3 to 0 by changing demand. And what you figure out is that you've got to sell 702 units to break even. Again, what does that tell you? That tells you that if you're thinking about option 3, if you think that your demand is less than 702, you definitely shouldn't do it. If you think that it is greater than 702, option 3 will be profitable. But what it's not telling you is if option 3 is the best option. Okay, so when you see these break-even numbers, they are break-even for each of those options independent of the other things that you have choices about. Okay, it's not about that. The break-even is just telling you the point at which you lose or make money on that option. Okay, because it's actually pretty clear that if your demand was around the 701, 702, that no, you wouldn't choose option 3. You'd make more money if you chose option 2. Okay, so it wasn't saying choose option 3 if you hit that demand number. No, that's not what it's saying. It's just saying that above 702 and above, that you would make money with option 3, not as much money as you might make with something else, but you will make money because they are independent decisions of each other. I mean, it's not a decision. They're independent evaluations from each other. All you're doing is saying where did you break even with each of those 3, which is a different question than asking when would option 1 be equal to option 2? Because what you're figuring out here, hopefully, is that, let me put the next one in here too, and I'll probably can talk and type at the same time. I get type anyway. Okay, give up. All right, so what you probably figured out in looking at this is that when you have really low demand, you can't afford to be buying big expensive machines. Yeah, granted, are the variable costs really high? Yes, but you can't afford the expensive machines. Your demand has to get up to a point where you can afford the machine that brings your variable costs down. Okay, and then when you have just tons of demand, you get the really expensive machine because now all of a sudden your variable cost is only $15. But the question is, when does that happen? When would we switch over? At what demand level would we switch over from option 1 to option 2? And it's not about those break-even numbers. That's not what those break-even numbers tell you. Okay? So we can figure that out though by just doing a mathematical formula right here that we can then force its result to be a certain number in a goal seek, and it would tell us what the demand is that will make these 2 things equally attractive alternatives. Okay, that would make them equal to each other. What kind of comparison could could you put, just a mathematical formula, no function, a mathematical formula, and it can then be used, that cell can then be used in a goal seek, where basically it can tell you what demand makes those two things equal to each other. Any thoughts? So what we're eventually wanting to do is, if those two things were equal to each other, then this would be equal. Their profit levels would be equal, right? So in this cell, if we look at the difference in these profit levels, it doesn't actually matter which way you go on this one. Take option 1 minus option 2 profit, or vice versa. If we look at the difference in those profit levels, and we put that in that cell, and then we make that our objective cell for our goal seek, force that to 0, you're finding the demand that would make those two profit levels the same. Okay. So now go into goal seek, force that cell that has the difference between the two profits, force it to 0. When it's 0, they're the same. How do you do that? By changing the demand number. And that's exactly what it did. If you have 600 units of demand, plug that into these formulas, that gives you the exact same profit on option 1 and option 2. If you had 600, I'll just put a little 600 over here. So I'll change in a minute. Now it's saying, if you hit 600, that's when you make the decision potentially to switch over to option 2, to buy that expensive machine and start using it. Well, we can do the exact same thing. We can do the exact same thing when we're comparing option 2 and option 3 to each other. We just find the difference between option 2 and option 3, subtract either way you want to. Find the difference between those two, force that difference to be 0 with a goal seek. Force that difference to be 0 by changing the demand level. You know, at what demand level would those two profit levels be exactly the same? How do I force it to be the same? If the difference is 0. Okay, if the difference between them is 0. Click OK. And we discover that it actually takes getting as high as 2,000 in order to, when this plugs in, give you the exact same profit, therefore 0 difference between the two. It takes till you get to the 2,000. So while those first 3 numbers over there were independently telling you where each of those options broke even, these numbers are now giving you more information of how would you know when to switch between options. If you think your demand is less than 50, don't do this at all, okay? But if it's between 50 and 600, you come out ahead using option 1. If it's between 600 and 2,000, you come out ahead using option 2. And if it's over 2,000, then you come out ahead using option 3. You have to get large scale in order to afford the more expensive machine that drops your variable prices down to a much better point. Okay. So those numbers will allow you to compare. The break-even numbers don't allow you to compare. They're not comparison numbers. They're individually, independently, where each of those options broke even. Does that make sense? So I don't know when, but like the first time a bazillion years ago that I did this problem, this is the way I set it up. Okay. But I do want you to realize that you might pull out that exact same problem and just see it in a different way. So, and this will be on the finished file. I'm not going to work these. I just want to show you something. Maybe you would rather put the options in this one. Well, it doesn't matter. Put the options in columns instead of in rows. Well, then you'd have something, well, exactly like, this is not exactly a flip of that, but you just could set it up this way. Or maybe you want to set it up where you've got everything, none of it's separated out, like selling price and demand, maybe none of that's separated out, in that case, revenue's not separated out. If you don't separate those two out, these have to be references to those cells, okay? They do have to be references to those cells, so you've gotta be careful about that. But you can just set it up completely differently, put all the information up there, revenue, cost, profit, boom, these two things are just extra. You're gonna get the same answer. These are three completely different looking things. What we did, the two things that are on here, and this is just to point out that you may look at it and see the structure in a different way, and that's all right, okay? It's all right for you to see the structure in a different way. In the end, if you set it up properly, you're gonna get the same answers. You know, you're gonna get the exact same answers. So anyway, I threw that in there, so when you see that on the finished file, you're like, well, what is this? We didn't do this. No, I'm just trying to show you some alternative structures for the same, because it's a small problem. It's a small problem. Okay, so our next, not too much, okay. The very lightly shaded cells. Sorry about that. They should be darker than that. You should be able to see them. These are all my input given numbers. There's, eventually when you figure out what the question is, that's gonna be our, an uncertain changing cell value. But if you looked at the PowerPoint tells you, well, it tells you all these data values which are here. You make widgets, and we make three different models, a basic, a great, and a super. And they have different material costs, levels, labor requirements. We sell them at different amounts. We have different amounts of demand per day. But in the place that we make these, there are fixed costs for the day associated with just fixed costs for everybody. Okay? And then the labor cost, regardless of which of these things you are working on, the labor rate is the same. It's $40. All right. They're gonna want us to fill in, and I usually like to have these all boxed off. They're gonna want us to fill in all these things. What's the variable cost per unit? Now I'm gonna start going through this quicker so we can get to the end of this one. But the variable cost per unit in this case would be the materials in B7 plus the labor hours times the labor rate. Make sure that the labor rate is an absolute reference. So B7 plus B8 times an absolute reference to B4. Okay, so basically it's gonna be $50 plus another $80 in labor. Okay, it's gonna be $130. And since I put the absolute references in, I see I have a higher variable cost per unit for the great and even higher for the super. Okay, so what's our profit margin? You know what this really ought to say? Really ought to say unit profit margin, because that would make it make more sense. I mean, be very clear at least that it's the unit profit margin. Well, a profit margin, profit is your revenue minus your cost. Well, when you're talking about just one unit, the revenue is the selling price. And the cost, we just figured out unit variable cost. So basically, you sell these things for $200, the unit cost is $130, you make $70 off of this. And gosh, that would drive me insane. Let's fix that. Okay, and then I'm gonna, I'm gonna copy that across, and you can see what the unit profit is for each of them. They're all profitable on their own, not so high profits for the super. You can see that a little bit. There we go. And then the profit per day is just basically gonna be a matter of, well, what was your unit profit and how many of them do you anticipate selling each day right there, the demand per day. Okay, so $70, we sell 12 of them a day, $840. Now here's the problem so far at this point. We haven't actually accounted for fixed costs anywhere. Yeah.
Is that also supposed to be unit profit per day, or is like? Or like, because that
No,
didn't take
it's
account the.
profit per day because you're taking the unit profit, which is $70, and multiplying it by 12 units. So it's just the profit on the basic per day.
Cause what about the fixed cost per day? Where would that?
Okay, so
go?
that's an overall, that's what we're about to do right now. So that's an overall fixed cost. What we didn't take the time to do was prorate that out to the basic, the great, and the super. We didn't take time to prorate it out. But we're gonna be just working with the overall number. And so we'll go ahead and take the profit per day of basic and great and super. Wait, I need to put a sum function in there. The basic, the great, and the super, okay? And subtract the fixed cost out of that, which would end up being the exact same as had we prorated it into each one and then summed them up. I mean, in the end, it's numbers gonna be the same, okay? So we're just kind of easy route here. We're just taking the fixed costs off at the end. And discover that while it looked like individually these things were all profitable, but when you put it all together and you take those fixed costs out, you're actually losing money. Okay, so you actually end up losing money each day. That's not good. At this point, you could point to all kinds of things to figure out why you're losing money, and you could point to all kinds of things to try to figure out how not to lose money. But the bigger problems appear to be with the super widget that has very high material costs, higher labor requirements. There's a lot of things we could even look at just for that one item, okay? We could look at a lot of things, but what they've decided to look at is the labor requirement. They want to know if you could retrain your people that are working on the super widgets and you could get them a little bit faster each day. How long would it take before you would break even, overall break even? Okay. So what I have down here are some labels. It says day 1, 2, 3 all the way down to day 60. And what I want to do is put that originally on day 1, it takes them 5 hours. Don't link that cell. Okay, this is one time I'm going to tell you don't link that cell. Put the 5 in there. And then in the next cell, they wanted to see if you could make them 1% faster each day. Okay, well let's make this one 5 times 0.99. I just made it 1% faster. So on day 1, it took them 5 hours. On day 2, if we're training them, they're getting a little bit faster, and that pattern would continue on, and they keep getting a little bit faster each day. What was my point in doing that? Is to figure out on what day do we eventually not lose money? Do we eventually kind of break even? Well, if this is gonna be my input, these are just labels, okay? Those are just labels. If this is gonna be my input, varying the time that it takes them to do the super widget, I need to know what's my output. Well, my output would be looking at profit level. Looking at profit level to see what that would be.
Oh my god.
Okay. So I'm gonna make this one-way data table. Notice I am not picking up the column of labels. Those are just labels, labeling day 1, 2, 3. They are not part of the table. My input column is the time that it takes, getting 1% faster each day. My output column is going to fill in with profit. So when I make this data table, data with analysis, data table, my column input, my one-way tables are always gonna have column input because I'm gonna make them vertical, okay, would go right there in D8. Plug the 5, which is already there, 4.95, 4.9, 4.85, plug that in right there.
Wait, so you did a data table, right?
It's a data table, doing a data table. And this is now telling me if it takes them 5 hours, I lose $130 a day. I already knew that.
What's the column input cell?
The column input cell is D8.
Yeah, okay.
But my question was, how long will it take before we don't lose money anymore? And that takes us all the way down to day 26 before we eventually don't keep losing money. Okay, we finally break even, and then some, but we eventually are not making money by day 26. All right. This question said, how many days will it take? Okay, we're gonna finish this. This question said, how many days will it take before we're not losing money? It's 26 days, and the best way to answer this question was to lay this all out in a table. What that, in a data table that was labeled with days beside it, okay? But that's a different question than how fast do they need to be. If I wanna know how fast they need to be, it's obviously something in between here, 3.92 and 3.88. I don't know exactly what it is, but the better way to answer that question would have been to do a goal seek on this. Go in, and in your cell E15, do a data what if goal seek, force that to 0, that's break even, by changing how much time it takes them to produce the super widget in D8. So force E15 to be 0 by changing D8, and it'll tell you that they have to have a speed of 3.9166. If that, all other things being equal, if that's the only thing that we change, that's the speed they have to get to, 3.91. Is that surprising? No, it was obviously in between these two numbers somewhere, okay? But here's the thing about this, and the more important thing about this model. To answer those two different questions, we did two completely different things. To answer one question about if I get them faster and faster each day, how many days will it take before they are breaking even? I really needed the data table for that because I laid it all out beside numbered days to figure out it was day 26. That's a completely different question than how fast do they need to be in order for us to break even. That was a quick goal seek. And I find out that they need to be at 3.91667 hours. Okay. They have you plot this, and when you do go to plot it, just plot this one column and you can see the plot that I have on the finished file. But minus the fact that we're not gonna do the grade file, we are caught up, okay? And starting on Tuesday, at least, as long as everything goes okay in 1 o'clock, at least these two classes, the 10 and the 11:30, are now synced up, okay? And we will be starting solver stuff on Tuesday.